This is the largest lizard on Earth, and for 30 years, the entire scientific world had the way it kills completely wrong. The story everyone believed was almost elegant. A Komodo dragon bites you, and it doesn't matter if you get away. Its mouth is packed with rotting meat and toxic bacteria, and that bite alone is enough. You bleed, you go septic, and within days, you're dead, even if the dragon never touches you again. That whole bacteria stuff has been a scientific fairy tale. That's Dr. Brian Fry, a venom researcher at the University of Melbourne in 2009, after he did something nobody had bothered to do in 30 years of repeating the bacteria theory. He put a Komodo dragon in a medical scanner. What he found changed how we understand this animal completely. Tucked into the lower jaw were fully developed venom glands, producing a toxin that stops blood from clotting, crashes blood pressure, and sends prey into shock. Some of the compounds inside it are just as potent as the venom of the inland taipan, the most venomous snake alive. The bacteria were real. They just were never the weapon. The Komodo dragon is, and always has been, the largest venomous animal on the planet. And nobody realized it until an actual scan proved it. An adult can reach 3 meters and 100 kilograms, run in bursts faster than a human can sprint, and take down prey many times its own size using a bite built less like a predator's and more like a slow, engineered execution. For most of recorded human history, this animal simply wasn't part of the story. The wider world had no confirmed record of it until 1910, when a Dutch colonial lieutenant stationed on the neighboring island of Flores, Jacques Karel Henri van Stein van Hensbroek, kept hearing the same rumor from local sailors and pearl divers: a land crocodile living on nearby Komodo, large enough to kill a water buffalo. He sailed out to check, shot a specimen roughly 2.2 meters long, and sent the skin and a photograph back to Peter Owens, director of the Zoological Museum in Buitenzorg, Java. Owens quickly realized this wasn't a crocodile at all. It was an entirely undescribed species of monitor lizard, the largest ever documented alive, and he published the first formal scientific description in 1912. For every year of human civilization before that, an apex predator larger than a grown man had been living undisturbed and effectively unknown, 30 feet from the nearest fishing village, simply because nobody outside a handful of tiny islands had any reason to go looking. Yet almost nobody outside a handful of islands in eastern Indonesia will ever encounter one of these animals in the wild today, and that isn't an accident of geography. It's the entire reason the species still exists at all. Fewer than 4,000 Komodo dragons remain, confined almost entirely to Komodo, Rinca, Flores, and a scattering of smaller islands inside what is now Komodo National Park. It is one of the smallest wild ranges of any apex predator on the planet. The people who do share the islands with this animal have had generations to learn its habits, and even that hasn't been enough to make the relationship fully safe. On a Saturday in 2007, an 8-year-old boy on Komodo Island walked behind a bush to relieve himself. His uncle, a fisherman working nearby, heard the screaming seconds later. A Komodo dragon had seized him by the waist and was thrashing him from side to side, the same motion it uses to tear meat from a carcass too large to swallow whole. The uncle threw rocks until the animal finally released the boy and retreated into the brush. It didn't matter. The child died from massive blood loss roughly 30 minutes later. Park officials confirmed something almost as unsettling as the attack itself. It was the first fatal Komodo dragon attack on a human recorded in 33 years. An entire generation had grown up on that island believing, reasonably, that the dragons simply didn't do this anymore. 2 years later, in March of 2009, a 31-year-old fruit picker named Muhammad Anwar climbed a sugar apple tree on the same island. He fell. 2 Komodo dragons had been waiting beneath it. By the time a neighbor found him, he was bleeding heavily from bites across his hands, body, legs, and neck. He died at a clinic on a nearby island shortly after. It was, at the time, the second confirmed fatal attack in barely more than 2 years. after 33 years without one. The obvious question is why? If this animal is this dangerous, deaths remain this rare. The honest answer has almost nothing to do with the dragon being gentle and everything to do with basic exposure. Fewer than 4,000 of these animals exist. Confined to a handful of islands, most people will never set foot on. The roughly 1,700 residents who do live alongside them have generations of inherited knowledge about avoidance, and tourists are required to move through the park with armed guides carrying long forked sticks specifically designed to fend off a charging dragon. Outside of that narrow, carefully managed overlap, a human being essentially never encounters a wild Komodo dragon at all. That isolation is the only real safety margin that exists. It is not a biological limit on the animal's capability. It's a geographic accident, and geographic accidents can change. Komodo National Park now receives well over 100,000 visitors a year, a figure that keeps climbing as the islands become a more established stop on Indonesian tourism routes, meaning more people moving through dragon habitat every single season than at almost any point in the species' recorded history. Rising sea levels are simultaneously shrinking the low-lying grassland these islands depend on for the deer and buffalo populations dragons rely on, which could eventually push hungrier, more food-stressed animals closer to the same trails and camps that tourists use. Neither trend guarantees more attacks, but both point in the same direction, and the margin that has kept human encounters this rare for decades was never guaranteed to hold as both lines keep moving toward each other. What makes an encounter so dangerous once it happens isn't just the venom, it's the hunting strategy built around it. Unlike an ambush predator that kills outright, a Komodo dragon is built to lose the fight in the short term and win it days later. After a bite, the dragon backs off and simply follows, sometimes for hours, sometimes for days, tracking its prey by scent using a forked tongue that flicks in and out to sample the air, delivering scent particles directly to a specialized structure in the roof of the mouth called the Jacobson's organ. Because the tongue is forked, the dragon can compare the concentration of a scent between its left and right tips, essentially triangulating direction the way stereo hearing lets an animal locate a sound. Under the right wind conditions, that system is sensitive enough to detect a carcass or a bleeding, weakening animal from several kilometers away. As the venom works, the animal weakens, disoriented and losing blood, until it eventually collapses from shock. The dragon, and often several others drawn in by the smell of blood, simply waits for that moment and then feeds. It's a strategy that trades speed for patience, letting biochemistry and one of the most sensitive tracking systems in the animal kingdom do the work that teeth and claws alone can't. Speed is still part of the equation, at least at close range. In short bursts, a Komodo dragon can hit roughly 13 miles per hour, faster than most humans can sprint over the same distance, though it can't sustain that pace for long. It's also a capable swimmer, moving easily between islands in the archipelago, and its usual pace on land is a slow, deliberate 2 to 3 miles an hour, conserving energy for the explosive strike that actually matters. Once the strike lands, in a real sense, the outcome is already decided. The victim doesn't need to be caught again. It just needs to be found. Here's the part that surprises almost everyone who looks at the actual research. The bite itself, measured purely as raw force, is embarrassingly weak. A team led by Brian Fry, the same researcher who identified the venom glands, modeled the Komodo dragon's maximum bite force directly and found it topped out around 39 newtons. A saltwater crocodile of comparable size bites down with roughly 252 newtons, about 6.5 times harder. Even a large domestic dog bites down harder. By some comparisons, a Komodo dragon's raw bite force lands somewhere in the range of a 3.5-pound fennec fox, an animal that fits in a person's arms. If force alone decided the outcome, this would be one of the least dangerous large predators on the planet. What actually makes the bite lethal has nothing to do with crushing power and everything to do with the design underneath it. 60 curved, serrated teeth built purely for slicing, a neck and body engineered to pull backward through flesh once the teeth are in, and now the venom working underneath all of it. The dragon doesn't need a strong bite. It only needs one good cut. And when a dragon does feed, it does so with a level of efficiency that borders on absurd. An adult can consume up to 80% of its own body weight in a single meal, then go weeks, sometimes months, without eating again, its metabolism slowing to match. It's the physiology of an animal built around scarcity, not abundance, engineered to make one successful kill last as long as biologically possible. That same scarcity shapes the most brutal part of a young Komodo dragon's life, and it isn't predation from another species. Cannibalism makes up an estimated 10% of an adult dragon's diet, and the primary targets are the smaller, weaker members of its own kind. To survive it, hatchlings spend their first 2 to 3 years of life almost entirely in the trees, using sharp claws and a prehensile tail to navigate branches 10 meters off the ground, completely out of reach of the heavier adults that would otherwise eat them on sight. They forage up there for insects, geckos, and bird eggs, effectively living an entirely different life than the one they'll eventually grow into, until their body mass finally makes climbing impractical, and they're forced down into the same terrestrial world as the predators that used to hunt them. If the venom discovery in 2009 upended how scientists understood this animal's biology, what happened in the mid-2000s upended something even more fundamental, the assumption that a female Komodo dragon needs a male at all. In 2006, researchers confirmed through genetic fingerprinting that a female named Flora at Chester Zoo in England, who had never once been housed with a male, had laid a clutch of viable eggs entirely on her own. Genetic testing ruled out stored sperm completely. The offspring were hers alone, produced through a rare form of asexual reproduction called parthenogenesis. A second female at the London Zoo, kept isolated from males for over 2 years, had done the exact same thing months earlier. Because of how sex is determined in this species, every single offspring produced this way is male, which means a single female, if she ever washed up alone on an uninhabited island, could theoretically found an entire new population by herself, laying eggs, producing sons, and then breeding normally with them once they matured. Nobody expected to find that capability lurking inside one of the largest, most physically dominant predators on the planet, and scientists still aren't entirely sure whether it's an ancient, dormant trait finally observed or a genuinely new adaptation. None of this happens in a vacuum. On the islands where it lives, the Komodo dragon sits at the absolute top of the food chain, and its presence shapes everything beneath it. It's one of the primary natural checks on the Timor deer and water buffalo populations that share its habitat, culling the sick, the old, and the unlucky in a way that keeps herbivore numbers from overrunning a genuinely fragile island ecosystem. Deer in particular make up the overwhelming majority of an adult dragon's diet, and the relationship between predator and prey on these islands has been running long enough that the deer themselves show measurable behavioral adaptations built around avoiding a Komodo ambush, staying alert near trail edges and dense brush where a dragon is most likely to be lying in wait. Remove the dragon, and the entire balance of vegetation, grazing pressure, and species composition on these islands would shift in ways that are difficult to fully predict, because nothing else on Komodo, Rinca, or Flores fills the same role. There is no second apex predator waiting to take over the niche. It is, in the most literal sense, an apex predator holding together an ecosystem that exists almost nowhere else on Earth, on islands so small and so isolated that losing this one species could plausibly unravel the whole thing. That isolation, the very thing that makes the ecosystem so fragile, is also the reason human encounters remain as rare as they do. Park rangers who work inside Komodo National Park aren't exempt from risk simply because they know the animal well. In one incident, a ranger was bitten on the hands and legs after a dragon entered his sleeping quarters at night, a reminder that familiarity with an animal this patient and this opportunistic doesn't equal safety, only better odds. What makes the Komodo dragon worth this much attention isn't a long list of confirmed kills. It's how much of what we thought we understood about this animal turned out to be wrong, and how recently that correction happened. For 30 years, the scientific explanation for its deadliest weapon was, by the researcher's own description, a fairy tale, repeated in textbooks until someone finally bothered to check. Its bite, measured directly, turns out to be weaker than a housecat's, which should make it one of the least dangerous large predators alive, if the venom underneath it didn't make that number almost irrelevant. Its reproductive biology defies one of the most basic rules most people assume applies to every large vertebrate on the planet: a female able to found an entire new population without ever encountering a male. Its juveniles live an entire secret life in the canopy, just to avoid being eaten by their own parents. And on an island where a species this large and this venomous went completely undocumented by the outside world until a colonial lieutenant chased down a rumor in 1910, the honest answer to almost every question about it is still, at some level, we're not entirely sure. That, more than any single attack, is what should actually unsettle you. Not that the dragon is dangerous, that we've been so confidently wrong about it, on point after point. For most of the century, we've known it exists, and only found out by accident. One scan, one genetic test, one skeptical researcher at a time. Somewhere on those same handful of islands right now, there is almost certainly something about this animal that still hasn't been discovered, quietly waiting, the same way the venom did for someone to finally think to look.